Well, welcome everyone. Thanks so much for taking the time to join us today. We have lots of great content to share with you that should leave you with value and next steps. So I'll kick us off here. We are at the top of the hour. Welcome to Web Mapping 101, creating dynamic web maps with geospatial data. Today I am joined by our three presenters, Sinai, Dylan, and Donald. So I'll pass things over to Sinai to introduce yourself.
Sure. Hi, everyone. My name's Sinai Mendoza. I'm on the Customer Solutions team.
Hey everybody, my name is Dylan Patterson. I'm a technical support specialist here on the product support team for FME Flow.
Hey guys, my name is Don Matir. I'm also a technical support specialist, but more so on the FME form side.
Awesome. If you do have any questions at all during the webinar, please do get those into the questions tab on the bottom right. The chat tab, if you are just joining us, please send out a chat to let us know where you are joining from today. If you do have any audio or video issues at all during the webinar, we also have that handy help button on the bottom left. So just click that and it'll give you 4 simple steps to take. If you'd like to download the slides and follow along live, a couple places you can do that under handouts, apps on the bottom right. And then you can also just click the download button on the top right of the PDF in this live stream room. And I'll hand it over to Donald for our agenda.
Yeah, thanks, Elizabeth. I'm just going to quickly run through the agenda and just to see what to expect today. So I'm going to kick us off with the overview, which is web mapping and how it works. And then I'll lead straight into getting data into ArcGIS Online and a simple HTML, which we'll see our first demo. I'll then hand it over to Dylan, who will go through the working with vector tiles. And then Sinai will, she will run through the 3D web mapping. Dylan will then pick it up again and walk through the WebSockets. And then I'll finish this up with a conclusion. Elizabeth then will just go quickly through the resources and next steps. And then we're going to have a Q&A at the end of the webinar. So without further ado, let's begin. So good morning to all and welcome to our webinar, Web Mapping 101. My name is Don Matir and I'll kick us off with an introduction into web mapping. So what is web mapping? Web mapping is the process of using the internet to visualize, analyze, and share your geospatial data through a map. With web maps, you can not only display data in a web map, but also provide a way to analyze the data as well. These maps can be distributed to anyone, anywhere, at any time. But why would you want a web map? A web map is a great way to display your geographic information and share it with the world. Anyone can click a link and view a web map to find important information like routing advice, upcoming weather patterns, or perhaps just finding the nearest store location. We all use web maps every day, or at least pretty much every day, and this webinar will help you get started in making your own. Web maps often contain a base map with other layers on top of it. The base map acts as a reference point for the layers on top. Most web maps that you see today are interactive. This allows users to find the information they need and explore the data by allowing them to view certain areas by zooming in and out and being able to select features. There are 2 primary types of web mapping. The first type is no-code web mapping applications. During this webinar, we're going to primarily focus on this type of web mapping. And a no-code web mapping application should allow you to create a web map for you without any code. It's easy to get started as you just need to import your data. It's hosted for you and the analysis is built into the platform. The second approach is custom web mapping APIs. This would involve reading documentation of different APIs and creating a custom web map by using JavaScript, CSS, or HTML. However, using FME, you can create basic web maps without any code. There are many different web mapping applications you can choose from. ArcGIS Online is probably the most popular application used, but other options include Carto and Mapbox, as well as QGIS and Cesium.js. It's also important to note that some business intelligence tools or BI tools will have mapping capabilities as well. These include Tableau Online, Qlik, Power BI, as well as Google Looker and SAP Analytics Cloud. The image shown here is from a BI webinar we did a few years ago using Qlik. There are many popular web mapping APIs available. Looking at our slide here from left to right, we have a Mapbox example where data can be streamed directly to the map. Next, we have Google Maps example, which I'm sure you're all familiar with. And finally, we have an example from ArcGIS API. If you want to see more examples of web mapping, we have many online at safe.com/demos. FME has a wide range of tools for creating features that will help you create your own web map. These are just a few examples of these amazing tools. GeoJSON is a popular one, and we are going to see that in the next section during a demo. Not only is FME great for creating features, but it also has many tools for creating web pages. Here are some examples. The HTML report generator being a popular choice. We'll also see this in the next section during the demo. But how can I get my geographic data into a web map? Well, FME can do that. It's as easy as importing your data, such as shapefiles, CAD files, or database layers into FME. Then you can transform the data into web-friendly formats like GeoJSON, KML, or MB tiles, and enhance it with attributes for styling or interactivity. Once ready, output the data and upload it to a web server or cloud platform. And there you have it. You'll have your own web map published. In this section, I'm going to show you how easy it is to get your data into ArcGIS Online and also to be represented on a simple HTML page. FME can make this seamless and extremely efficient. FME can both read in data from ArcGIS Online and write it out. Data can be derived from many sources and added to ArcGIS Online on a schedule. We have resources available to help you get started with this process, so be sure to check them out. They're very valuable. Once data is in ArcGIS Online, you can visualize and analyze it, and you can share it with the public. If you have an existing HTML page, you can easily embed a map that was created in ArcGIS Online. These maps can be viewed through a web browser or a mobile device. You can also create simple web maps in FME using no code. FME can take geographic information from any format and push it to a HTML page. If needed, you can add custom code to enhance your results. So I'm going to move on to the demo portion of this section, which is translating data to ArcGIS Online. I'll quickly explain what our goal is. So our goal is we have some JSON data that is updated regularly, and I need to post it to ArcGIS Online. But I don't want to manually transform and upload this data every 2 weeks. This is where FME is so useful. FME can help you transform this data and post it. By utilizing FME, we can now have an automated way of pushing data to ArcGIS Online. We'll just begin the demo here now. Welcome to this demo, translating data to ArcGIS Online and creating a simple web map. For the purpose of this demo, we have built it out already just to be cautious of time. But from this workbench, we're greeted with readers, writers, and transformers, all connecting to each other. Now, this may look complicated at first, but I'm going to walk through everything here and show how easy it is to get some really cool results with FME. You'll notice we have a URL which contains earthquake data. So what we did here was add a GeoJSON reader into our workspace. Once the GeoJSON is added, we can run it to see if everything was loaded in correctly. As you can see, the information from the website has now been added into FME through the GeoJSON reader. Keep in mind, it doesn't have to be an online source. It can also be a file source. Next here, we're going to manage our data. The data that was loaded in looks quite complicated. I'd like to be able to clean up our data and make it easier to understand. For this, we'll use an attribute manager. Opening up our attribute manager, I'll show you what I changed. I wanted to change the names of some of our attributes. For example, I changed the input attribute of mag and renamed it magnitude. I also wanted to change the time to make sure it's in seconds. I also wanted to change the category based on the magnitude. Checking magnitude online, I added in test conditions. For example, anything that is above 2.5 and below 5.4 magnitude, then the value is set as often felt but only causes minor damage. Next, we want to push this to ArcGIS Online. But first, we're going to take that date time, which is an epoch time, and convert it to FME time. This can be achieved using a date time converter. Your datetime attributes will be selected as time updated, and input format will be selected as seconds. From here, we connect to our writer, which allows us to push our data to ArcGIS Online. With this writer, we can run this workflow, and we will now take a look in ArcGIS Online and see if our data has been added. Visualizing the data, it shows the magnitudes of the earthquakes, the location, and the time. It's just that easy. I'm also going to show how to take this data and put it into a HTML report generator. From the Attribute Manager, we can connect to our date-time converter, which once again is making it an easier format to read. Another Attribute Manager is added so we can have a pop-up with our HTML report generator of whatever data we deem necessary. This next section is a small section on statistics. This is so we can create a histogram, which will then be turned into a bar chart. The statistics calculator is creating a histogram using the magnitudes. For each level of magnitude we're going to create a count of them. In the HTML report section, we have added two HTML report generators. The first one we add in are page contents, a section, a header, titled earthquake data, and then we'll also select map, selecting Esri Leaflet. The label attribute selected for this will be pop-up, and our base map is going to use satellite imagery. In our second HTML report generator, we're going to create a bar chart from our statistics section. In the transformer, we select chart, choosing our x-axis as value, and the y-axis will be count. From here, we can now run our workspace again and create this HTML. As you can see, a map and bar chart has been created. The HTML report is a great way for you to be able to visualize what your data looks like. As you can see, the magnitude of the earthquakes can be seen on the bottom of the chart, while the count is along the side. You can also click on earthquakes to learn more about their magnitude and time. So this wraps up our demo on translating data to ArcGIS Online and creating a simple web map. So I'd like to hand it off to Dylan, who is going to run through custom vector tilesets. Thank you.
Great, thanks, Donald. Let's talk about custom vector tilesets. So vector tilesets are collections of points, lines, and polygons organized into zoom levels. You'll see more detail when zoomed in and a coarser view when zoomed out. They're really responsive and adapt instantly to user interaction with the map, making for a smooth and intuitive experience. For large datasets, they're great because they render quickly and ensure your map stays fast, even if it has a lot of data on it. You can create custom tilesets from your own data with FME or explore third-party sources online for even more flexibility. So to demystify this image on the right and nerd out a little bit, I have a basic example of how a vector tile is created. Here, a base map at zoom level 1 has 2 columns and 2 rows. If I have a feature in column 1, row 1, my tile writer will put this in a folder called 1-1-1.mvt for Mapbox vector tile, representing my zoom level, column, and row, or Z, X, Y. So say I want to create custom vector tiles so that large dynamic data sets can be displayed in my web maps. but tiling conversion libraries require special knowledge, and I don't want to use any custom code. Therefore, I can use one of FME's tileset writers to translate my spatial data. Finally, I will have a vector tileset that can be hosted and maintained, used in a variety of mapping applications. Great, so moving into the demo. Here in my workspace, you'll notice that my starting data consists of census administrative boundaries. I have census divisions, census subdivisions, census areas, and dissemination blocks, each of which show increasing detail. Inside the feature writer, we're writing to a Mapbox vector tileset writer. Each feature type is a different layer, and each layer has a different zoom level. And as I move down my layer list, I'm increasing the zoom level so we see smaller census boundaries the closer we get to the ground. Now, for the sake of time, I've already run this workflow. You can see I have about 19,000 files down here, but that's only about 10 megabytes worth of data. I've written this into a folder called Vancouver Census Boundaries. Inside, as I mentioned, these numbers represent all the different zoom levels. Our Mapbox vector tile writer has also created a metadata.json file, which contains our layer names and attributes. Inside each of these zoom levels, we have a column folder. Inside this column folder, we have our Mapbox vector tile itself, representing the row number. Now, if we want to see these tiles on the web, we need to upload them to something like a server or a database. For this workflow, I use the Amazon S3 connector to directly upload my tile set to a public S3 bucket, but you could use other cloud providers as well, like Azure or Dropbox. You just need to make sure that your data is publicly available if your web map is publicly available. So after our vector tile sets have been uploaded, we can create a simple workspace using the HTML report generator to display the data. In the HTML report generator, we're going to use a base map of Mapbox GL.js since we're using Mapbox vector tiles. And instead of tiles from our workspace in the vector layer box, we'll post our S3 bucket link for each layer on the map. I'll upload that to FME Flow, which I've already done here. And so I'm just going to go run workspace and select the data streaming service, and we'll be brought to a center point. And here you can see I have no data at this zoom level. So to save space and just shorten my processing time, I've set my minimum zoom level to 14. But after reaching zoom level 14, you can start to see my dissemination blocks appear, then my dissemination areas, my census subdivisions as the data becomes coarser, and then finally my area of interest, my overall census division. So that's not too bad for a 10-minute workflow. You can see just how fast and responsive these tiles are. So beyond vectors, we also have a variety of raster tile transformers like the raster tiler and the webmap tiler. Additionally, we have an OGC webmap tile service reader and writer and an OGC geopackage tile reader writer. And then we also have a generic tiler that works for rasters or vectors. And we support even more tile formats like 3D, which Sinai is going to talk about more. Off to you, Sinai.
Thanks, Dylan. So up until now, we've been creating web maps with flat features. In this next section, we're going to bring our maps into the third dimension. So 3D really opens up new possibilities for visualization and analysis. Imagine all of your 3D models, so BIMs, landscapes, or CAD designs displayed in a browser. Sharing via a web URL is way more convenient than sending these really large data sets often or asking users to install specialized software. So FME supports various 3D formats that are web ready out of the box. whether that's creating cesium tiles for 3D models and point clouds, generating index 3D scene layers for Esri's ArcGIS Pro and ArcGIS Online. You can work with 3JS, a robust JavaScript library with built-in VR support, or write to GLTF, an open standard for 3D scenes and models. There's a lot to choose from. So in many workflows, we might be starting with a 2D dataset, but we can make that 3D in just a few transformations. So in this example, our resident visualization expert, Dimitri, has started with a 2D OpenStreetMap layer of Washington and combined it with the DSM and DTM datasets from the Washington LiDAR portal. So in a workspace, he leveraged vector and raster layers to calculate building heights and footprints. And the result was a 3-dimensional dataset that was easily converted into a web-ready cesium tile set, which you can just see in the image 5 there. Looks really good. So imagine building a 3D map of the city you live in that allows users to explore and navigate the landscape. This might seem like a complex task that requires specialized knowledge, but it's actually surprisingly simple. So transformers make it easy to take basic 2D data like a GeoJSON and JPEG to generate 3D buildings and produce a cesium tile set for use in a sort of a basic JavaScript-enabled HTML web page. The result is a 3D web map that can be easily shared with others. So let's walk through this process in our next demo. So we start in a workspace where we're reading in 2-dimensional GeoJSON dataset of the city of Surrey. So in the data inspector, we can see polygons for all of our different buildings. In the feature information window, notice that each building has an elevation attribute. We'll use this attribute to create 3D buildings. First, we reproject into UTM. Then we can use the extruder transformer to create a surface geometry with that building height parameter. So this produces a 3D layer that we can orbit around in our data inspector enabled for 3D. So if we want to make this city a little more realistic, we can add texture with the appearance setter transformer. We're going to run this transformer with a JPEG of snow to create sort of a winter themed cityscape. You could do this with literally any image though, so let's try something more fun. Here I've got a JPEG of bananas, my breakfast. We'll rerun it and just take a second to render. And here is our city of Surrey again, this time transformed into a Donkey Kong ready map. Now that we've created a 3D layer, we can use the cesium 3D tileset writer to produce features that can be streamed on a browser. Once all of these tiles are written, you can go over to the cesium viewer and bring them onto the web. It just takes a few seconds to upload. And cesium has this really handy code preview option where we can see what the tilesets will look like on a web map. So here is our buildings. Looking all right. And it's just as easy as grabbing this JavaScript snippet to the left and dropping it into your own web mapping application, maybe adding some raster background maps. End result is a pretty neat looking 3D web map. So when creating 3D web maps, it's important to follow a few best practices. You want to use transformers to reduce data complexity as much as possible. This helps ensure smooth performance and, most importantly, avoids crashing your browser. This does happen on occasion. Build quality checks into your workspaces so errors in 3D data can stand out in unexpected and sometimes hilarious ways, but let FME catch those issues before your data goes live. Nothing spoils a map faster than outdated data, so with FME automations, we can actually schedule updates and automatically upload hosted datasets, ensuring your maps are always current. FME can create and update every layer of your 3D web maps, whether that's the vector features or raster background maps, with support for a wide wide variety of formats. You can build complete end-to-end cohesive maps. Beyond the extruder that we used in the demo, FME offers tools like the 3D Forcer, Surface Modeler, or Triangulator to handle all of your 3D transformation needs. And that wraps up our look at 3D web mapping. Now I'll hand it over to Dylan to dive into web mapping in real time.
Great. Let's talk about using WebSockets with FME. So if you aren't too familiar with WebSockets, they are a web protocol, kind of like HTTPS or FTP. It's generally used for high velocity data streams, and it uses a single persistent connection. WebSockets are often used for things like chat applications, stock prices, safety monitoring, equipment status from IoT devices, things that are updated frequently or need to be closely monitored. You can use WebSockets with FME in the following modes. Notification mode, where a WebSocket can be used to trigger an action, like using the WebSocket trigger in a FME Flow automation to run a job when a stream becomes active, or a message streaming mode, which we're going to focus on today. And that's where we're dealing with continuous high velocity data that is running pretty much nonstop. To connect to a WebSocket stream in FME Workbench, we use the WebSocket connector transformer. So let's talk about the WebSocket connector transformer a little bit more. You can use it to receive data continuously or in a batch. So say I just want 1,000 features from my stream, I can do that. We can also stream data out with it continuously. So you can use both these actions or either one in a workspace. Streaming mode works really well if you can dedicate an FME engine to running a workspace continuously. But if your stream is only active intermittently, or you don't want to commit an engine, that's no worries. You can use our CPU usage engines instead. Great. So say I have a real-time data stream that I want to visualize in a downstream application. The data needs to be cleaned, and I don't want to run multiple job updates or run separate workspaces. I can use FME to route the stream into a workspace and format it how I want. The result will be that I have a very happy downstream application with a correctly formatted, error-free stream. So moving into the demo. So to start, we have a workspace that contains a simulated stream of ADSB flight data. Since the stream will run indefinitely, I've used a sampler here so we can see what's happening in this workspace. The data needs a bit of cleaning. I won't go into too much detail about this, but here we're just exposing the raw detail. You can see it's a little bit nested and it isn't super usable for me in this form. So I'm going to use the JSON fragmenter to get rid of that nested structure and take everything out. And then I'll use a tester to discard anything that I can't use. Finally, I'm using a JSON extractor just to assign each element in the array into an FME attribute that can actually be used in my workspace. So we'll move that data into a JSON templater, which is something we often use with the WebSocket connector. You can see here, I have a variety of attributes. I can rename these if I'd like, or keep them as the same name as they are in my workspace. Clicking this on this table on the left, I can insert my attribute values, which will be dynamically populated at runtime. So I've named this templated JSON WSF message for my WebSocket message. And then to connect to our FME Flow WebSocket server, we need to connect using the WebSocket or WebSocket Secure protocol. So here I'm using WebSocket Secure, which uses port 443. But if I was running this locally, I could use port 7078. So I need to use a connection preamble to establish contact with FME Flow. So I just want to tell it that I'm opening a stream and then give it the stream name and ID. So we don't need to remember the syntax. This transformer has a handy template here. You just pop that in and then replace it with your stream IDs, or just ID, as I have in my case. I only have one stream. We're going to use the send action, but here you can see we can either send or receive. And then in my send options, I need to specify the data that I want to transmit. And I need to tell the WebSocket server that I'm sending data as well. So again, we have a template for this. Just pop that in. and replace it with your WebSocket message. So we're done with this workspace now, and we can upload it to FME Flow. So to make things simple, and because I want this job running 24/7, I'm going to run it as a stream. So I already have this set up, and as I mentioned before, streams require a dedicated engine. So I'm just going to do that here. But as I mentioned, if you have a stream that isn't running 24/7, it might be better for you to use CPU's engines instead. That way you're only charged when there is actually data to process. And so now that all this is set up, it's just going to run until I turn it off. Now to visualize this, I can use FME and use a very familiar looking workspace here with an HTML transformer. Inside my HTML report generator, I'm going to choose the custom HTML option at the bottom. On the right here, I have a really simple HTML document. All I have here is links to my dependencies. So I'm pulling in my leaflet library for the base map, and then my custom JavaScript CSS hosted on AWS. And then inside my HTML body, all I have here is a div that's required to hold the map by leaflet. Now I'm not using a whole lot of custom code here, and I'll show you what I mean. All I'm doing is setting up my base map. I'm connecting to my FME Flow WebSocket server using the same parameters I used in my workspace. So opening up a connection to FME Flow and connecting to the ST plane stream, but from the browser side. And then the rest of this code is just creating leaflet icons on the map. And then at the bottom here, I'm just creating some pop-ups so we can get a little bit of information on each plane. Now, in order to display this, we can run this workspace in data streaming mode. Now, zooming out, it's just going to take the map a little bit to populate with all the plane locations. But once all our planes are on the map, we'll see the locations change as our JavaScript overwrites the icon location with the new coordinates. And if I want to see some data coming in, I can just click on one of these. And by opening up the developer console here, I can see the data streaming into my workspace. And then opening up, you can see I have the data that I put in from my workbench. Now, if you wanted to go one step further and put this in something like a gallery app, I can use a webhook to do that. And that makes it really easy to access from my organization. So here you can see, same kind of idea. Great. So yeah, wrapping up, using WebSockets with FME is a super powerful tool to manage your data streams. And with that, I'll pass it off to Donald to wrap us up.
Yeah, thanks, Dylan. That was very interesting. So this leads us to the conclusion of our web mapping webinar. We'll go through a few slides here reviewing what we have learned. So it's easy to get into web mapping with just a few clicks in FME. If you're new to web maps, you don't need to worry about custom code since we provide base map templates that work instantly with your data. The HTML report generator is the place to go, and you have the flexibility to make your web maps as simple or as customized as you like. The best part about web mapping is that you can share your data visually and in an easy to understand way to anyone, anywhere, at any time. They're easy to use for even non-technical people, so it's a great way to make your information and decision-making products widely available with the help of FME. As you can see, Safe Software is an ever-growing company with a large community worldwide. We've been doing this for over 30 years, and we now work with over 25,000 organizations worldwide from 128 countries. We have an active community of over 37,000 users, and it's constantly growing. Safe Software started back in the 90s. We primarily focused on GIS and geospatial data, but as you can see through the years, we responded to our customers' needs, and we now support over 400 data types in FME. From geospatial data through to location intelligence and IT, our goal is to enable your data where, when, and how it's needed, regardless of its source. FME is the only all data, any AI platform that helps you take control of your data and make it work for you. I'm just going to hand it over to Elizabeth now, who will quickly run through the resources. Thank you.
Amazing. Thanks so much, Donald, Dylan, and Sinai, all of you for today's webinar content. I'll just take us through some resources before we head into Q&A. So we do have a few specific to today's topic. What I'd recommend, if you'd like to take a look through this list here, is clicking that download button on the top right of the deck, and then that way you can navigate through the links and kind of have that as a handy reference. But yeah, otherwise we'll also have this posted on the website once we send out that follow-up email, and you can reference them there as well. But is there any the team wants to highlight or make a note of in particular on this slide? I know we did customize these resources specifically to tie into this webinar topic today.
The cesium tiles one is basically an exact replica of my demo, sans the banana JPEG. You can add in your own there. But there is quite a bit of chatter just on our forums too about web mapping. So I'd recommend, if there's something that's not listed here, to just do a little search and see what comes up, because there could be a discussion somewhere about what you're interested in.
Yeah, you'll also find plenty on the community as well. So be sure to check that out.
Okay, great tips. Thanks, team. In terms of other resources, we're all about free resources here at SAFE. We have our Academy, free instructor-led training there, and also highlight, we have lots of upcoming webinars, safe.com/webinars, so check those out. For next steps here today, we'd love to help you get started. Get in touch with us at info@safe, and we can help you with anything data. Our FME Accelerator course, if you are newer to FME, I highly recommend this course. It's 90 minutes and free of charge, and it's a great place to get started with the basics of FME. If you are a member of our community, we have a community badge code that you can redeem today as a thank you for joining us. I will just drop that in the chat now. And if you aren't a member of the community, check it out. It's a great place to network with other users alike, gain solutions. Yeah, as the team just mentioned, you can search the various forums there as well for various topics.
Perfect. Thank you, Elizabeth. My name is Moyen, and I will be guiding us through the Q&A session right now. And I'll just have our presenters join me on stage, and we can take a look at some of the questions that have come in. I do see a question that's come in. I can promote it now.
Awesome. Yeah. Question is, can I build web maps in FME using my ArcGIS Enterprise base maps as a background? Yes, short answer. I think there's a couple ways that you could do this. One that comes to mind is using the HTML report generator, which we showed in a couple of our demos, using the Esri Leaflet option, where you can just enter in your feature service URL that points to your map. And I guess that is more geared towards vector feature services now that I'm thinking about it, but there should be an option to use base maps as well. Dylan or Donald, have you used feature services or base maps in any of your web maps?
I haven't tried it myself, but I'd imagine you would be able to.
Yeah.
Yeah, it'd be the same as Dylan, but I don't believe there's any issues.
Yeah, I guess the other approach that we could take to this is you can always use FME to write that data to your enterprise ArcGIS, and then use that in maybe a custom web application that you're using, pointing to that feature service URL, and having FME as part of the process in that way as well.
Awesome. Yeah, we did have a question come in as well, and I can highlight that now. Here.
Can the appearance setter put raw stereo imagery or ortho imagery on top of 3D building models? This one I'm not quite sure about. If the rest of the team isn't sure either, we could definitely find out and follow up with an answer after the webinar.
Yeah, that sounds great. Yeah, we'll definitely follow up with them post-webinar. Yeah, we did have some other questions come in through the throughout the webinar as well. Is there any that any of our presenters today wanted to highlight for the other attendees?
Yeah, Yash was asking some questions about available free web mapping services. We gave some suggestions there in the chat, including things like Mapbox or using, our own tiling readers and writers to create tiles from our own data and host those somewhere. Sans the cost of the hosting service, that is sort of a free way to create web maps. We also have some transformers like the web map tiler and raster tiler that help you do that for base maps. The HTML report generator does support things like Mapbox and Leaflet as well. Mapbox has a tiered plan that's really quite good. I think we've linked as well to our integrations page, just filtering through the word tiles to bring up some more options there. But there's probably many now that out there that I haven't kept up with. So it's definitely worth sort of poking around on the web and seeing what web mapping services are available. As Yash mentioned too, we do have a product idea for Azure Maps. So if that's something you'd like to see, let us know and we'll add your support to that.
We have another question coming in.
So for this question, chime in, Dylan or Donald, if you think I'm misinterpreting this, but I think it's asking if we can only sort of utilize or install some libraries from ArcGIS to use with FME. As far as I know, that's not an option. FME will just leverage the existing ArcGIS license that you have on that machine. It's appropriate for the product. And that's our supported sort of integration method with ArcGIS. I'd suggest reaching out to your account manager at Esri to get a more complete answer on your limitations there, but that's as far as I know.
Awesome. Yeah, I don't think more questions are coming in, but we'll definitely leave the webinar running for another 5 minutes. So everyone can download the slides or get in any last questions. If we didn't get to your question, we will definitely follow up with you after the webinar. And yeah, if you have a moment to fill out our webinar survey, we do appreciate any feedback as well. But yeah, I just wanted to thank everyone for attending today's session, as well as our presenters for helping out with Q&A today. Yeah, that's all for me. Thank you, everyone.
Thanks, everyone.
Yeah, thanks for joining.
Yeah, thanks.
Bye.